All right, let's talk about something that's been around forever but is still one of the most dangerous threats on the web: SQL injection. It's this hidden danger lurking right where you keep your most important stuff, inside your database. Let's dive in.
I want you to think about this for a second. Every time you log into a website, search for a product, or fill out a form, you're basically having a conversation with a database. But what if a hacker could just, jump into that conversation? What if that innocent little search bar was actually a key that could unlock a company's entire vault of secrets?
Well, that's not just a what-if scenario. That's exactly what SQL injection is. It's a nasty software flaw where an application gets tricked into running database commands it should never, ever run. And we're not talking about a simple bug here. This is a wide-open backdoor that can expose, well, everything.
So, first up, let's really break down what SQL injection is, and we're going to see how this danger can hide in places you least expect, right there in plain sight.
And don't for a second think this is just a problem for, the big tech giants. No, this can hit pretty much any application that talks to a database. We're talking e-commerce sites holding your credit card info, internal tools at your job. Basically, if it's got a form or a search bar, it's a potential target.
Okay, so we know what it is, but so what? Why is this such a massive deal? Well, that's what we're getting into next. Understanding the impact is where things get really serious.
Look, the damage here can be absolutely devastating. And it's not just about stealing data, although, yeah, that's a huge part of it. An attacker could literally change information, completely take over the server to launch other attacks, or, just flip a switch and shut the whole system down. It's bad.
And the really scary part? It just takes one mistake, a single line of bad code, one form field that wasn't checked properly. That is all it takes for an attacker to get full control. Just like that, you've handed over the keys to the entire kingdom.
So, the big question is, how does this actually work? Let's get our hands dirty here. We're going to walk through a classic attack, step by step, and pinpoint the exact piece of code that swings the door wide open.
It all boils down to one simple, fundamental mistake. You could call it the original sin of database security: mixing your data with your code. The application literally takes whatever a user types into a box and glues it right into a database command, treating that input as a trusted instruction. A huge mistake.
Okay, check this out. Here's a super common piece of code. The application is just trying to find a customer's name by looking up their ID. See how it's got the command all set up, just waiting for that ID number to get plugged in at the end? Looks pretty harmless, doesn't it?
But what if the user doesn't enter a simple number? What if instead an attacker types in this? It looks like gibberish, I know, but trust me, every single character in there has a very specific job to do. This is the injection part.
And boom, here's what happens. The app blindly sticks that malicious text onto its command and the entire logic of the query changes. It's no longer asking for the customer with ID 1. Now it's asking for customers where the ID is 1 or where 2 is greater than 1. And since 2 is always greater than 1, that condition is always true. So the database just says, okay, and spits back every single customer name it has. Oh, and those 2 little dashes at the end? That's a comment. It tells the database to just ignore anything that comes after it. It's deviously simple. Game over.
Yeah, that's pretty terrifying. But the good news is there's a really solid, straightforward way to prevent this. So let's talk about the defense, the silver bullet that stops this kind of attack dead in its tracks.
The whole defense strategy is built on one core idea, one golden rule. You have to separate your code from your data. That's it. Whatever a user types in is data, period. It should never, ever be allowed to become part of the command itself.
And you know what? The fix is actually pretty simple. Look at the left. That's the bad way, where we're just gluing the user's input onto the end of our command. But on the right, that's the solution. See that question mark? That's a placeholder. The database gets the command first with the placeholder, and then it gets the user's data separately. This way, the data is just data. It has zero chance of changing the logic of the command.
So this gives us a really clear two-step defense. Step 1, validate your input. Always make sure it's the right format, the right type, what you're actually expecting. And step 2, this is the big one. Use those parameterized queries we just talked about. This is the absolute gold standard for preventing SQL injection.
And this isn't some weird, obscure technique. Pretty much every modern language does it. Here's how it looks in Python. You see the %? That's the placeholder. The actual id variable is passed in separately, and the database driver takes care of plugging it in safely.
Here it is again in Java. It's the same exact idea, right? You prepare the statement with a placeholder, that question mark again, and then you safely bind the user's input to it. It's the same secure pattern, no matter what language you're using.
Now, fixing the code is absolutely the most critical step. But real security, bulletproof security, needs a bigger picture mindset. So for our last section, let's talk about how to build a virtual Fort Knox around your data.
It's all about having layers of defense. For starters, use the principle of least privilege. That just means database accounts should only have the bare minimum permissions they need to do their job, and nothing more. Of course, you should be encrypting sensitive data, doing regular security audits to find weak spots, and please keep all your software up to date with the latest security patches.
And hey, security isn't just about the code. It's also about how your network is set up. You'd be shocked how many databases get hacked without any clever injection at all, just because they were left wide open to the internet on their default ports. Slap a weaker default password on there, and you're just asking for trouble. Locking these down is absolutely critical.
And that really drives home a key point here. You can write the most perfect, secure application code in the world, but if the database server itself is misconfigured or has its own vulnerabilities, you're still at risk. This isn't just a developer's problem or a database admin's problem. Security is a team sport.
And at the end of the day, it all comes down to this. 1. It just takes one little slip-up, one input field that wasn't checked, one weak password. That's all it takes to bring the whole thing crashing down. Vigilance is everything.
So, I want to leave you with a question to think about for your own work. When you look at your applications, ask yourself this. Is it having a secure, controlled conversation with its data, or is it unknowingly taking orders from complete strangers on the internet? The answer to that question, well, it could make all the difference.